Hello everyone, and welcome to our session. I'm Amanda Gray, I teach STEM.
And I'm Chad Ward, I teach computer science.
And we're from Kenwood Middle School in Clarksville, Tennessee. We're excited to be here with you today to discuss ways to implement hands-on learning in the computer science classroom to boost student engagement. Before we get started, we'd love to hear who is joining us in this session. Please open a new tab and type in the bit.ly link you see on the screen. We use bit.ly and hyperlinks often in our classroom, so you'll see them a few times in our session. Once you're on our Padlet, click the plus sign at the bottom right-hand corner and add a note to the board. Please include your name, where you're located, and if you're currently implementing any hands-on learning in your classroom. If you don't do any kind of physical computing yet, that's okay. Tell us what you think you might want to add to your class or any hesitations you have about adding hands-on learning. You can go ahead and pause this video here while you complete that.
Here's a quick overview of what you can expect from this presentation. You will learn ways to integrate equipment and physical computing into your curriculum. Amanda and I will discuss how we currently integrate hands-on learning in our classrooms and resources for implementation. You will discover ways to successfully introduce these concepts into your classroom. We will discuss lesson plans, classroom structure, and how to grade when completing these activities in class. And finally, we will discuss funding opportunities for obtaining equipment.
This is my 8th year of teaching and my first year teaching STEM. I previously taught kindergarten through 8th grade music and middle school band. One constant throughout my teaching career has been my passion for implementing hands-on learning. Giving students the opportunity to be immersed in experiential learning not only boosts engagement and excitement, but it also directly integrates real-world applications and 21st century skills. The hands-on activities we share today will challenge your students in skills such as problem-solving, decision-making, critical thinking, logical thinking, and effective communication.
This is my 6th year teaching and my 2nd year teaching computer science. Previous to this, I've taught 8th grade science, as well as middle school math and social studies. I am a firm believer in integrating technology into the classroom, which is how I ended up in my role as a computer science teacher. A canceled drone competition allowed me to integrate drones into my new computer science class. Seeing the excitement and curiosity displayed in my students motivated me to create a class with a large focus on hands-on learning and physical computing. While I'm still working on best practices to use in the classroom, I'm excited to share some of the ways that I've increased student engagement and interest in computer science.
We are going to include several additional resources that could be used in your classrooms toward the end of the session, as well as in the session links Google Sheet. However, we are specifically going to be sharing what we use in our classrooms and the equipment and programs that have worked well for us. So please understand that this is not an exhaustive list, and we're still learning about a ton of other resources that are out there. Also, since we're middle school teachers, all of our experience is really going to focus on the middle school grade band, but everything we talk about can be modified for upper or lower grade levels.
Using drones in the classroom is an exciting way to hook students into coding. Teledrones feature block coding, but can also be programmed using Python and JavaScript for more advanced options for students. At Kenwood, we use Drone Blocks, which is coding software which features color-coded blocks, which allows students to drag and drop to build their code. This easy-to-use software has many benefits. For those using Google Tools, Drone Blocks can be installed as a Google Chrome extension, which makes it a quick access system that doesn't require authorization for district installation. Drone Blocks allow students to learn and apply codes such as loops and variables, as well as explore Boolean logic, functions, and math operations. With some clever lesson design, you can create real-world examples that the students can explore in code. For example, students can create a drone show by flying patterns using loops. Or maybe the students complete a PBL to brainstorm and run mock humanitarian missions while they develop variables and functions. By using drones, students are motivated to complete their code accurately so they can see the outcome of their work. In terms of problem-solving process, the use of drones highlights the prepare, try, and reflect steps. Because the students are able to visualize what the outcome of their drone movements should be, they can reflect on the movements of the drones actually competed and enhance their debugging and troubleshooting skills when they determine the necessary corrections. As a fun introduction to coding with drones, my students have played drone bowling. With this activity, they were able to learn the basic coding blocks by using the drone as a bowling ball to knock over empty bottles for pins. Students were challenged to take off, adjust their height and speed, and safely return and land the drone. Another activity my students completed was creating shapes in the skies using loops. For this task, students had to use loops to create a template for flying shapes. They also had to apply their math skills to calculate angles for their turns. This was a great example of real-world applications for coding with drones.
Do you have students who constantly play games with the spacebar and arrow key? Teach them a fun new way to play these games using the Makey Makey kit. For an inexpensive option, you can purchase a couple kits and use them as a station rotation in class. You can also purchase a class pack, which comes in a set of 12 kits, 12 booster packs, and many additional materials for larger projects. Using Makey Makey lessons in your class is an awesome way to integrate STEM and teaching students about how circuits work through coding and familiar games. The first step is to learn about basic open and closed circuits and how they work in order to build a circuit using the Makey Makey kit. This can be done using a piece of cardboard and aluminum foil or anything else that is a conductor, such as fruit. Once the students build their Makey Makey board, they can connect it to their computers and start playing. Using the Makey Makey circuit board, they now have control of keys such as the spacebar and the arrow keys by holding the alligator clip in one hand and touching the conductor in the other to close the circuit. They can even work in pairs and have one person hold the alligator clip and the second person touch the conductor and close the circuit by fist bumping. My students get a pretty big kick out of that one. One of my favorite parts of this activity is that you can use pre-made games on Scratch, games specifically for Makey Makey through the plug and play on their website, or you can have students code their own games on Scratch. I've used this as a station rotation in my STEM class, and the students really get excited about building a simple circuit and using it to play games they design.
Grove boards from Seed Studio are an inexpensive and easy way to introduce Arduino coding into the classroom. The kit includes an Arduino-based board with 11 different programmable components, such as an LED display, buzzer, or push-button controls. One of the benefits of using this kit is that all the components are integrated into a circuit board. This allows the student to focus on coding and not have to worry as much about basic electronics and making connections with wires and resistors, which can lead to a frustrating experience. Seed Studio offers basic lessons on their websites for programming and using the different components. Using these as a guideline, you can customize a lesson plan for your students to manipulate the inputs and variables to change the output of their code. For example, the first lesson codes an LED light to blink, which can be tied to real-world connections for your students. Perhaps your students explore radio towers, and you have your students program the board to flash at the rate required for warning lights on a radio tower. I had my students investigate lighthouses and code the rate of flash for a lighthouse that's being automated. Another idea would be to use the temperature, pressure, and humidity sensors to have your students design a weather station. The integrated components make the board approachable with real-world applications. With these kits, you can ensure that the students understand the written code and then move them to more elaborate kits like Arduino education kits, which will be discussed later in this session.
Ozobots are an entertaining tool to introduce concepts of sequential programming and computational thinking. These cute little bots use color codes for programming and can lead to better understanding of sequence and allow students to transition into block coding. Ozobots are a very effective tool for showing students how computer programming functions in a literal sense. As a line-following robot that can change speed, direction, or colors based on the color code command it is given, they cannot make decisions and will precisely follow instructions that are provided to them. Simple mazes can be created to help students with computational thinking, as they would need to figure out the maze solution and then analyze what the bot would need to do each step of the way. Using the simple color codes and their corresponding commands, you can introduce concepts like if-then statements, or have the bots respond to a series of code while it runs in a circular path to explain loops. For a cross-curricular twist, I've used Ozobots in my class to teach and reinforce measurement skills. Students have to design a racetrack for the bots using lines of a certain length or a specific total length, such as the 50-centimeter racetrack challenge. In this challenge, students put their programming and measurement skills to the test to try to design a track that includes carefully selected commands intended to help the bot complete the track the fastest. LEGO Robotics is a classic and fun way to introduce physical computing into the computer science classroom. Robotics kits have been available for many years, which means there's a vast number of resources that can help you integrate LEGO Robotics into your classroom. In terms of resources, LEGO Education has a website dedicated to lesson plans, as well as plenty of third-party options that offer lessons to help you and your students tackle LEGO Robotics.
One of the challenges I faced with LEGO Robotics, especially with the use of the older EV3 kits, was the complexity of the software. While the software allows for endless programming possibilities, it can be a little daunting. LEGO has addressed this with improved software that is easier to use. Also, for students that are proficient in Scratch, there is an EV3 extension available that connects the unit to Scratch.
What we like about LEGO Robotics is the flexibility that comes with the equipment and how you choose to integrate it in your teaching. Students can build simple bots and focus more on the programming, or you can give them a challenge and let them design and program a bot that works. You could also form a team as an after-school club and compete in a variety of competitions available in the area. This year, Kenwood Middle School's LEGO Robotics team was an option in our school's after-school program, and we competed for the first time with First LEGO League. Between the flexibility and the vast resources available, the possibilities of robotics integration in your classroom are endless.
Arduino education kits are a great way to really delve into computer science. Not only do these kits allow for coding, they also introduce basic electronics, circuits, and how computers work.
The kit will come with everything the student needs to create and code programmable circuits. The kit will include an Arduino board, different components, a breadboard for prototyping, a multimeter, and enough wires and resistors to create multiple components. When you purchase the kit, it will include very thorough lessons as well as an activity log and guidance. These kits are perfect for students who can self-pace or for working in pairs in a class.
As the students work through the lessons, they will get background knowledge on the concepts presented, make real-world connections with example circuits used, and gain an understanding of how electronics and programming work together. They also get hands-on exposure to material that is usually lacking in the computer science classroom. With additional resources and access to forums, students can expand on what they've learned with different projects. These kits can be used to create simple robots or to build machines. For example, my students will be using these kits to create a laser maze. They will use a light sensor in conjunction with a laser pointer and mirrors to create a grid. They will use the sensor to detect the light, and if the beam is broken, it will sound an alarm and display a warning light. Arduino education kits offer a great way to teach some more in-depth computer science concepts while giving hands-on exposure.
Remember, we shared with you at the beginning of this presentation that we're focusing on tools and resources that we use in our classroom. We'd also like to take an opportunity to share some additional options with you to possibly explore.
These options haven't been used yet in our classroom, but we know many educators who have found success with them. The first company we'd like to mention is BirdBrain Technologies. They have two different options of robotics kits, the Hummingbird Kit and the Finch Kit. BirdBrain kits allow the users to build and code robots and come with access to free materials for a variety of activities like programming and classroom activities. BirdBrain also offers a trial demo for 60 days, which allows you to try the robot kits before you buy them.
For those that use Code.org curriculum in your classroom, you might be interested in exploring Circuit Playground from Adafruit. This microcontroller has different components integrated into it, similar to, but smaller than, the Grove boards we discussed earlier in this session. Code.org's Unit 6 Physical Computing and the CS Discoveries course is designed for the Circuit Playground and allows students to explore the microcontroller.
Another microcontroller with integrated components worth mentioning is the microbit. Microsoft's MakeCode programs are designed to work with the microbit, implementing both block and written code. This is a relatively cheap device that can be also used with Python and Scratch. You can get the basic starter kit for under $50. Finally, if you're looking for options to engage your advanced students, consider using Raspberry Pi kits. These can be programmed for just about anything, from robotics to smart home automation, from gaming systems to microcomputers. There are communities of Raspberry Pi users out there that have demonstrated the vast possibilities of these devices.
Now that we've shown you some different options for integrating hands-on physical computing, you're probably wondering, how can I implement this into my classroom?
We're going to discuss several different options for implementing these tools into your classroom and specifically share ways we have successfully integrated them into ours. One of the easiest ways is to take advantage of the options that have pre-made lesson plans. Many of these options have full lessons that are aligned with National Computer Science standards and can be customized to work well in your classroom. You can teach these lessons as a full unit to reinforce standards already taught or in smaller blocks as a way to introduce a new topic.
Another fantastic way to implement these options is to create a station rotation for students. This way you can continue using your tried and true lessons while incorporating a physical computing component, allowing you to use material you already have and add to it. One of the benefits of using station rotations is that it's significantly cheaper than purchasing class sets of these tools and can allow for more personalized exploration. Students working in small groups can collaborate on different tasks and support each other in their learning. This approach to learning offers engaging activities while also differentiating to student needs. Remember, a course like computer science or STEM is a discovery course where you are the facilitator guiding students to make connections, reach their potential, and practice all those 21st century skills.
I like to implement physical computing at the end of a quarter or semester once the students have been taught all the standards and concepts. Now they can put these concepts to use and physically see the results of their coding. This can also be a great way to do a check for understanding on the standards, as you can have the students explain the concepts being used at any particular time.
If you are ambitious, you could create a unit around the equipment and use physical computing as your main teaching tool. Many of these options can be used to teach a variety of computer science concepts. Don't be afraid to think outside the box and try something different for your students. You'll find that they will respond well to something new and exciting, especially when they can see the physical outcome and real-world connections.
Still a little hesitant to implement hands-on learning on top of the curriculum you currently teach? That's okay. Many teachers have a set curriculum, like Code.org, that they follow and struggle to find the time or the ability to have more activities into their class schedule. or they only see their students for a semester or quarter and simply can't fit everything into that time frame. If this is you, I'd suggest starting a club or an after-school program to test out options. This way you can work with a small group of students or a pilot team to explore different opportunities for physical computing and offer feedback without sacrificing classroom time.
The next most important question to ask is, how will I grade this? Something I keep in mind when grading in my STEM class is to focus on understanding of the standards and concepts, as well as student growth and reflection. You grade the process, not the product. Whether you implement the engineering design process, the problem-solving process, or anything else, one of the most important aspects is reflection and communication. Many times you will have students who simply fail at a project or lesson. Should they fail the assignment? Absolutely not. Offer your students the opportunity to reflect on or self-assess their learning. What was supposed to happen and why did mine not work? Where could I have improved along the way? If I had to give advice to another student completing this project, what would I tell them? Most of my formative assessment grades take the form of checks for understanding throughout the project, usually in a Google form, where I ask students about concepts and vocabulary that align with the state standards. If I'm doing a summative assessment grade on a project, such as a 3D print or a research presentation, I will provide a rubric with exact requirements for students to use as reference when completing their project. In my opinion, the reflection that students complete at the end of a unit or project is the most valuable insight to their learning. A lot of times, students will write amazing comments and stories they experienced while completing the project that shed light on their aha moments that help me improve my teaching for the next group. I especially love the class discussions from the reflections. Even though many students discuss their work in class as they work, it's always exciting to see them compare and contrast their experiences and identify how they use skills such as problem solving, critical thinking, and decision making.
One of the biggest challenges you're going to face is how to get equipment for your classroom. As with any supply issues in education, you're going to have to get creative. First, I would suggest that you explore the equipment as stations or as an extension activity if you're just getting started. This way you're not trying to purchase class sets of anything right away, and you have the opportunity to see how the students respond. Some places like BirdBrain Technologies have equipment trial programs for teachers. Reach out to the companies to see if they have any programs that will allow you to try it or purchase the equipment at a discounted rate.
Consider the costs of each option and decide where to start, especially if you are considering similar types of equipment. For example, you might want to start with Grove boards to introduce Arduino, which can be purchased for about $30 instead of their $350 education kit. Or perhaps use the drones as buy-in at $120 each instead of the $300 LEGO robotics kits. When deciding which equipment to purchase, consider your students. Maybe even get them in on the decision-making process. Students love sharing their opinion and having a say in their learning. If you want true buy-in, consider asking your students to help design the course and what activities or equipment will be used. Teach the students how to research the equipment and evaluate options to make the best decision. You will have taught them a valuable lesson in resource management and budgeting and boost student engagement in your class at the same time.
Don't forget about those grants. As computer science expands in schools, there are more funding options available out there, and you can find them with a little legwork. At Kenwood, we expanded our computer science program with funds from a TVA grant. The TVA grant is available every year to allow educators to enhance their STEM classrooms with additional funding. You can find information about the TVA grant on the TSIN website. The National Science Foundation also has a website that will have information about various grants available for computer science educators. The link will be included on our resource page. There's money out there, we just have to find it.
And finally, don't forget to check with your TSIN STEM hubs. The STEM hubs carry a lot of different kits that are available for teachers to use in their lending library. These kits are free and you can reserve them online. If they don't have what you need, suggest that they add it to the STEM hub. Your STEM Hub would also be a great resource for where you might be able to source equipment or what kind of funding opportunities are available. Don't forget to sign up for the TSIN newsletter. We've made it to the end. We hope you've enjoyed hearing some ideas and have already started brainstorming some of your own.
To recap, this session has covered implementation of physical computing and hands-on learning in your computer science or STEM classroom, including how to fund it. We'd like to offer some resources to help get you started. By following the bit.ly displayed on the screen, you will find a list of resources that include where you can get equipment, guides offered by the manufacturers, and places to help you with plans or grants. We have also included a couple of sample lessons that you are free to explore or modify as you see fit. We hope that by utilizing these options that we have presented, you can increase engagement in your classroom. We have found that anytime we bring out equipment, the students are excited to participate and learn. By presenting a variety of different options to you, we believe that you can discover one that will work for you and your students. Remember, this is not a one-size-fits-all exhaustive list of ideas. Get creative and get your students involved.
Finally, we'd love to hear from you. If you navigate to the bit.ly displayed, there is a feedback form for you to complete on your own time. Let us know if you have tried an option and how it worked for you, or perhaps you have another resource that we didn't cover. We'd love to add it to our list. We've included our contact information as well. Please feel free to ask questions or seek clarification on anything we have covered in this session. Don't forget to check out the sample lesson plans in the resource sheet to help spark some ideas. Thank you for attending our session, and we hope you find engagement and success in your classrooms.